In the last video, we saw how to use the slope-intercept form to graph equations of lines, and we're going to do the same in this video, but this time it's not going to be quite so easy for us, because this time we're going to be looking at linear equations that are not yet in the slope-intercept form, so in order to use the form, we have to get the form. So let's take a look at this example here, where I do not have my y isolated yet. My job is to get that y isolated so that I can see the slope and see the y-intercept. So if I want to get y by itself and there's all this junk attached to it, I have to move everything out of the way. The first thing I'll do is relocate the x term. I want x on the right with the constant, which is already there. Since the x is currently negative, I'm going to relocate him by adding 2x to both sides. Remember, as we work with equations, we always want to keep everything balanced. Whatever we do on one side, we do the exact same thing to the other. So now negative 2x plus 2x has canceled away. It's no longer on that left-hand side. All that we have over there is the 5y. And on the right, we now have that positive 2x joining the negative 30, which was already there. So we're one step closer, trying to get that y by itself. Right now, there's a 5 attached to it with multiplication. We'll detach it with division. This is where we have to be kind of careful, because when I divide by 5 on the left, I have to divide by 5 on the right, but I'm dividing everybody by 5, not just the convenient guys. So on the left, 5y divided by 5 gives me y. There's the isolated y that I want for that slope-intercept form, so this is good. But now I got to be careful here. I can't only divide by 5 when it's convenient for me. I have to divide everybody by 5. So I'm going to have 2x divided by 5, which you kind of cringe at because it doesn't come out nice. I'm just going to write it as a fraction. So we have the 2 divided by 5 will be a fraction 2/5, and then I have that x. And now negative 30 divided by 5 gives me a nice negative 6. So I wound up with a nice number for my y-intercept, not a nice number for the slope, but that actually doesn't matter because we do think of the slope as a fraction, rise over run anyway. So the fact that that's a fraction doesn't deter me at all. But now I can look at that equation and I can easily see the slope of this line. It's the coefficient in front of x, which is in this case the 2/5. I can also at a glance see the y-intercept, which is always going to be found in your constant term, which is your number without the x attached to it. And again, we always write the y-intercept as 0, comma, whatever that number is. So in this case, 0, comma, negative 6. All right, so we've got all the information we need to graph this line. We're going to begin with the y-intercept. So we don't go left or right, we stay centered, but we go down 6. So I've got my initial point there. And then from there, I need to use the slope to count up or down, left or right, to figure out where the next points are. Like we did in the last video, let's see if we can write this fraction 2 different ways. Let's think of it in terms of different combinations of positives and negatives. So this is a positive 2/5, and I can think of that as positive 2 over positive 5. That's still positive 2/5. But I also could think of it as negative 2 over negative 5, which is still positive in the end, negative over negative. And so this gives me a couple different directions to think in. If this is rise over run, up, down versus left, right, vertical over horizontal, I can think of positive 2 rise, meaning up 2. I can think of a positive 5 run, meaning go to the right 5. Negative 2 for my rise would be going down. Negative 5 for my run would be going left. So I have two options. I can go up 2, right 5. I can go down 2, left 5. So let's see where that takes us. From our initial point, let's try this first option first. Let's go up 2, right 5. So from this initial point, if I go up 1, 2, and to the right 1, 2, 3, 4, 5, I wind up right here. And with just those 2 points, I can get my equation, but I'm going to want extra accuracy. So let's go one more time from this new point. Let's again go up 2, right 5. So from here, we'll go up 2, and then we will go right 1, 2, 3, 4, 5. And we have a second point. They're all in line with each other, which is good. I'm out of space to go this way any further, but it looks like I can continue going to the left. So let's try this other option. Let's now, from that initial y-intercept, let's go down to left 5. So down 1, 2, and then left 5. I need to get in front to make sure I'm kind of going straight there. And then from that new point, let's again go down 2. Let's see, down 2 and left 5. And we're about there. And so everything looks like it's lining up as it should. Let's take our straight edge and we will connect the dots. Oh, this is not well planned out. There we go. Let's take our straight edge, maybe, and connect the dots here. Not perfect because we are human, but we do want to make sure we get those arrows in there. I will say that the more points you put down, the more accuracy you have, but also the more accuracy I can read. So if you are putting those points down, even if your line's a little bit off, I'm able to tell what your intentions were because you're identifying where those points ought to be. So that's an example where we started off with an equation that wasn't really in the best format. We worked to get it in that slope-intercept form, and then it was just the same old from there. Look for the coefficient for your slope, look for the y-intercept, the constant for your y-intercept, and then we just put that information down into the graph to get our line. So let's look at a couple others. Okay, so here we have another example where we're given a linear equation, but it's just not in that slope-intercept form, so we have to do a little bit of manipulation first before we can identify the slope and the y-intercept. So as I look at this equation and I know that my goal is to get the y by itself, I start to relocate things and isolate that y. So first I'll identify the x term, which I do want to relocate to the right side. Since x is currently negative, I will add it to both sides to relocate it. And so now on the left, that negative x plus x will cancel away. All that's left on this left-hand side is the 2y. And now on the right side, I have that positive x, along with the positive 10 that was originally there. So now I've got one more step to get the y completely isolated. Since there's a 2 attached to it by multiplication, I'll detach it with division. But again, this is where we have to be careful to divide everything on both sides by 2, not just the terms for which it's convenient. So on the left, 2y divided by 2 is y, and there's my isolated y that I want. But now on the right side, I gotta be careful. If you don't see a number in front of x, remember it's assumed to be 1. If I have 1x divided by 2, it's not a nice whole number. So let's think of it as 1 over 2, that's just a half. So I have 1/2 x. And then the positive 10 over 2 turns out to be a nice positive 5. So the y-intercept turned out nice. The slope looked like a fraction, which might scare you off, but don't let it, because remember, a slope is the rise over run, so we have to think of it as a fraction anyway. That's actually convenient to see it that way. So now that we're in that slope-intercept form with the y isolated, x and constant on the other side, I can identify from here my slope of my line, which is my coefficient in front of x. I can also identify my y-intercept, which is my constant term, but I will write it as a point, 0, comma, that constant term 5. All right, so when I go to graph it, I begin with the y-intercept, which in this case begins up at positive 5. And then from there, I use my slope to count up or down, left or right, in different directions. So let's think of that slope a couple different ways to help us here. So 1/2 you can think of as positive 1 over positive 2, but you can also think of it as negative 1 over negative 2. Whether you have 1 divided by 2 or negative 1 divided by negative 2, it's still a half. It's still positive a half. Using those two different forms, though, it gives us a couple different combinations of directions. So rise over run, this could be a positive up over a positive right. Again, rise over run, this could be a negative down, and then a negative left. So from our initial point, we can either continue counting up 1 and right 2, or we can count down 1 and left 2. Let's see what happens when we do. So from that initial point, let's go up 1, right 2. Up 1, right 2 will put us about here. And those points are pretty close together. It technically is all I need to create a line, but I'm going to get a lot of flexibility when I connect those points because they're so close. So let's create additional points for that extra accuracy. So again, I want to go up 1, right 2. So up 1, right 2. And then again, up 1, right 2. And then up 1, right 2. And I am getting a little off here, I think. Up 1, right 2, and then I'm out of space. And then if I'm out of space in that direction, I want to try the other direction. Here are some other options. We can instead, from that initial point, go down 1, left 2. So down 1, left 2 would put us here. I can go down 1, left 2 again. Down 1, left 2. Down 1, left 2. Down 1, left 2. As many times as you need to fill in that space. And then I can take my straight edge, and I can see my human inaccuracy here, but that's okay. I'm going to go ahead and connect my dots as best I can and make sure I get those arrows on to again communicate that the line continues forever in both of these directions, that the up 1, right 2, up 1, right 2, or the down 1, left 2, down 1, left 2, that pattern continues forever. That is the arrows. All right, so as with the last two examples, we again have a linear equation that is not yet in slope-intercept form, so we have some work to do. We want to isolate the y, so let's take that x term that's on the left and relocate it to the right where it belongs. Since it's currently a positive 5x over here on the left, let's detach it from the left using subtraction. We'll do the same thing on the other side to maintain that balance in the equation. So now the 5x minus 5x has gone away. We now have the 3y on the left side. On the right side, we have the negative 5x now, along with the positive 6 that was originally there. So we've relocated x, now we need to isolate the y. We need to divide by the 3 that's attached with multiplication. So when we divide by 3, remember we're dividing everything on both sides by that number, not just the things that are easy and convenient. So 3y divided by 3 is just y. Negative 5x divided by 3, we'll just write that as a fraction, negative 5/3 x. And then 6 divided by 3 will give us 2. Notice that as I write this linear equation in this format, when I do that division for the negative 5x over 3, I do write the fraction as a coefficient in front of x, and that x is in a neutral position. You could keep him upstairs, that's where he was originally. I like to write him in a neutral position so it's really clear that this is my coefficient in front and here's my x. Just make sure that it doesn't look like your x is down with the 3. That would be a problem because he's not supposed to go in the denominator there. But now that it's in that slope-intercept form, I can just at a glance take a look at this and see that the slope is that negative 5/3, that number in front of x. I can see that the y-intercept is that positive 2, so I'll write this y-intercept as the point 0, 2. All right, so we've written that slope-intercept form, we've gathered the information we need, and now we can go ahead and graph. We'll start with the y-intercept, which is up at positive 2. And then from there we use the slope to count either up and down, left and right, to figure out where to go. So let's think of a couple different ways that we can maybe write that fraction. Right now I have the negative in a neutral position, but I could have thought of it as being upstairs with the 5, where the downstairs would have been a positive. Or I could have put the negative downstairs with the 3, leaving the positive upstairs. As long as the negative is in just one location, we're good to go. So those two different options give me a down and right, or an up and left combination of movements. Let's try this first combination. So from my initial point, from my y-intercept, let's go down 5, right 3. So down 1, 2, 3, 4, 5, and right 1, 2, 3 to get our next point. That's all I need to get a line, but for that extra accuracy, let's go again from that point now down 1, 2, 3, 4, 5, and right 1, 2, and 3. And I think I'm out of space going this direction, so let's see if we can go the other direction. So if instead of going down 5, right 3, I wanted to look at this combination, I could think up 5, left 3. So from that initial point, let's go up 1, 2, 3, 4, 5, and left 1, 2, 3. And it looks like if I tried to go up 5 from there, I would run out of space. So I've got all the points that I can fit. I will go ahead and connect them using my straight edge. And again, we have to remember our arrows to say this goes on forever in both directions. Okay, for our last example, again, we have an equation that's not yet in slope-intercept form, so we've got work to do. We want to relocate that x term to the right. Since it is currently a positive 3x, we will move it or relocate it using subtraction. So let's subtract 3x from both sides to keep that balance. The 3x's now cancel from the left. We have a 4y on the left side. And on the right, we now have that negative 3x along with the negative 4 that was already there. So now to isolate the y, we'll detach the 4 using division. And remember, we have to do the same thing to every term on both sides, whether it's convenient or not. So 4y divided by 4 is just y. And then on the right side, negative 3x divided by 4, I'll go ahead and write my fraction, negative 3/4 x. And then negative 4 divided by 4 is negative 1. So again, I've got that slope-intercept form, and so now at a glance I can see the slope, which is that negative 3/4, the coefficient in front of x. And then this y-intercept I can also see. It's going to be the point 0, comma, whatever my constant is. So in this case, 0, comma, negative 1. And so when I go to graph it, this is all the information that I need to gather. I'm going to start with the y-intercept. If we're starting at negative 1, that's where we are there. And then I'll use the slope to count to find my other points. So I already have a fraction, but let's see if we can write this fraction a couple different ways just to help us with some different combinations. It is a negative fraction, so I can think of this as a negative 3 over a positive 4, which would be negative 3/4. I also could think of it as a positive 3 over a negative 4, again, negative 3/4. So this gives me two different ways to think of the movement. I can go down 3, right 4, or I can go up 3, left 4. So from this initial point, let's try this first version first. From the initial y-intercept, let's go down 3, right 4. So down 1, 2, 3, right 4. We'll do that again and again until we run out of space. So again, down 1, 2, 3, and right 4. It's going to put us at the 8. Here we go. And I'm out of space in that direction. So let's turn around and go the other way. Instead of down 3, right 4, let's go up 3, left 4. So again, from that initial point, if we go up 1, 2, 3, and left 1, 2, 3, 4, that'll put us about here. And I think we've got room for one more move, going up 1, 2, 3, and going right 4. We'll wind up right about here. And so again, once we've got all the points that will fit, we can go ahead and connect those points with a straight line. Again, remembering our arrows to show that the line continues in that fashion forever. So you've now seen several examples where we take a linear equation. Sometimes we have to do work to get to this point, sometimes we don't, but we want to see that slope-intercept form because in that form you can visually see the slope and the y-intercept at a glance, and those are the two pieces of information that we need to create the graph of a linear equation. So we've seen two different techniques. We've got the tables of values, which were kind of long-winded, but they were nice because they work for every kind of equation. And then we've got this nice efficient technique using the slope-intercept form. The only downside is that it only works for lines. It won't work for any other kind of equation, but when you can use it, it's pretty quick and efficient.